All right, let's jump right in. We're relying on AI for so much these days. I mean, everything from driving our cars to diagnosing diseases. But get this, these incredibly advanced AIs, they can be tricked. And tricked in ways that are almost totally invisible to our eyes. This is a huge blind spot, and it's something we really, really need to talk about.
And hey, this isn't some made-up what-if scenario. This actually happened. In a real test of a popular computer vision model, a picture of a cat was identified as a motor scooter. Yup, you heard that right. The AI was super confident about it too, so it just begs the question, right? How can a machine be so brilliant and yet so incredibly easy to fool?
Well, the answer has a name. It's called an adversarial attack. The best way to think about it is like an optical illusion, but one that's designed specifically for a machine. So to you and me, the image looks totally normal. But for the AI, these tiny, almost invisible, and very cleverly designed changes can completely flip what it thinks it's seeing. It just completely misreads what's right there in front of it. So fooling an AI into thinking a cat is a scooter might sound like a bit of harmless fun, right? But when you start thinking about the real world, well, that's a whole different story. When these models are actually deployed without us knowing about these weaknesses, the risks can get really, really serious. Just imagine an autonomous car. Its AI has to be perfect at reading road signs. Now, what if someone puts a few strategically placed stickers on a stop sign, so subtle you wouldn't even notice, and suddenly the car's AI sees a speed limit 60 sign instead? The results? I mean, you can imagine. It would be an absolute disaster.
Or what about in hospitals? We're using AI to read X-rays and MRIs. An attack here could make the AI completely miss a tumor, or maybe even worse, see one that isn't there, leading a perfectly healthy person down a path of terrifying tests. We're talking about literal life or death stakes here.
And it's not just cars and medicine. Think about a factory. They use computer vision for quality control, right? To spot defects. A clever attack could trick the system into giving a thumbs up to a dangerously flawed product. Next thing you know, it's out on the shelves, leading to recalls, lawsuits, a complete nightmare for everyone. Okay, so how on earth do we fix this? The answer isn't to just give up on AI. No way. The answer is to get a whole lot smarter about how we build and test these things. And that brings us to this really important idea called robustness testing. Robustness testing is basically a stress test for an AI's brain. Instead of just seeing if it works on a perfect, sunny day, we do the opposite. We intentionally try to trick it. We throw everything we can at it. Essentially, we act like the bad guys to find all the hidden weaknesses before a real attacker can. It's all about finding those blind spots so they can be fixed. Now, I know this might sound super technical and complicated, but the cool thing is there are tools popping up that make this way more accessible. So let's just walk through a really simple example of how you'd actually do this, how you'd put a model to the test. So the process is actually pretty straightforward. First, you just pick a model you want to test. You can grab one from a public place like Hugging Face. Then, and this is the important part, you pick an image and ask the model, hey, what do you think this is? You need to know its exact top answer. We call that the starting label. After that, you just plug the model, that starting label, and the image into a testing tool and hit go. The tool takes over from there and does all the hard work, basically running a whole bunch of simulated attacks to see where it breaks. And that last part brings us to what is maybe the single biggest pro tip for getting this right. It's not about what you think is in the picture. It's about what the model thinks is in the picture. So if you show it a cat and it says tiger cat, you have to use tiger cat for your test. If you just put in cat, the whole test will be off. You've got to start from its world, not yours.
All right, so the test is finished. What's next? Well, you get a report card for your AI, which is really cool. So let's check out the results for a food detection model that was tested on a super simple picture. Just a hamburger.
And the score is 52 out of 100. Yikes. That is not a great score. It's barely passing. Right away, that tells us this model has some pretty big problems. But the really useful part isn't just the final number, it's the details behind it.
See, the report breaks down how the model failed. It tells us it has a critical weakness against something called the Carlini and Wagner attack. That's a super sophisticated one that's really hard to defend against. It also has a high vulnerability to another one called FGSM, which is a bit more of a brute force method. But look, it does pretty well against things like blur and contrast changes. This is gold for a developer, because now they know exactly what kind of defenses they need to build. And here it is. This is what it actually looks like. On the left, you've got the original hamburger pic. The model sees it, no problem. On the right, That's the version after the attack. I mean, look at it. Can you even see a difference? It's almost impossible for us, but that tiny bit of digital noise was enough to completely break the AI's understanding. That right there is a successful adversarial attack.
So, what this all points to is a really fundamental change in how we should be thinking about building AI. We're moving away from this old idea of just build it and we'll fix the bugs later. Instead, we're moving toward a culture where safety and security are baked in from day one. So, why does all this matter so much? Well, for a few huge reasons. First, it makes security a priority right from the start, not something you tack on at the end. It gives developers the tools they need to build better, safer models. It helps everyone, from startups to big companies, choose the best and most secure open source models out there. And really, it creates a culture of responsibility. All of this comes together to do the one thing that matters most: build public trust in AI.
And that kind of leaves us with one big question to think about. As AI gets woven into, well, everything in our lives, the most important feature isn't going to be how fast it is or how much it can do. It's going to be trust. Can we rely on it? So the real question for all of us is, are we actually doing what it takes to build that trust in from the very beginning, from the very first line of code?